All right, class, today we're going to talk about some use cases of 2D arrays and some algorithms that we can use on that, and a couple little fun things that you may not have thought about doing with a 2D array. So let's go ahead and take a look at this. So let's assume that we're going to, or let's not assume, but we're gonna do a little exercise where we're going to work with some parallel arrays. So we're actually going to have three sets of data, three dimensions of data here. One 2D array and one standard array. So let's say that a company is keeping track of their sales in a 2D array. The rows are the months, and they move across tracking their sales each day in each of the columns. Now, the months are different lengths, and believe it or not, you can actually store arrays of different lengths in those rows. So you don't have to have the same width all the way across. That's what's called a jagged array. And we're going to say that they store their sales values in integers. We can talk about the security concerns about storing data as doubles for money because there are rounding errors, so we usually don't want to do that. But we've got some integer array that we'll call sales. And this is going to be passed in, we'll assume that this is in a method header, and we're going to be passed in this sales data. Now we're also going to want to average each month. It's going to be hard sometimes to figure out what's going on each month when we have all of that data. Think about 365 days of sales information. So we're going to want to create an averages for each month. So let's take in also in our header here, we're going to take in a double array that's going to store our averages, and we'll go ahead and call it averages. Averages. So this is in the method header. Maybe we call this average month, whatever. We don't really need the rest of the header. All we're thinking about is that we're getting passed in this data. So if we think about this data here, how can we do this? Well, we're going to have our data that's going to look something like this, right? We've got our 2D array. We're going to call sales, or is being called sales, right? And it's got its different sets of data. And some months are a little bit longer than others. So it's not necessarily an even set of data. At the same time, we also have our averages. Let's go ahead and abbreviate it there. And this goes on, right? It goes on down here for all 12 months. So what we're going to do is we're going to add up each row. Think about what an average is. An average is where we're going to take each row, we take all of the items there, we add them up, and then we divide by the number of elements that we have, or we divide by the number of columns in this case. And then we're going to save that value into the parallel location in our averages array. So our first row is going to be saved, or row 0, 0th index here is going to be saved into our 0th index over here. Our first index here is going to be saved into our first index there. The average is going to be saved in. Okay, so let's look at this in our code. Well, it's pretty simple. We do nested for loops, we find the averages and save them in. Simple, right? Okay, so let's actually do it. So we're going to first loop through those rows. So let's grab each integer, or let's grab each row. So int row equals 0, and our row is less than our sales dot length, and our row plus plus, increment row. Awesome. So now that we're moving row by row, we're going to need to average that row. So I'm going to create a double to keep track of my sum. This is going to help me avoid some casting later. But you can save this as an integer. And we'll set it to 0 to reset it every time we loop through to our row. Now we create our inner loop to go across the columns and add them to sum. So int column 0, 0, and our column is going to be less than our sales row dot length. This way, no matter how many days are in the month, we're going to be okay. And then we go ahead and increment column. Okay, so now we're going through and we do our basic algorithm for summing an array, where we're simply going to say sum gets the value at sales at that row and column position. And we loop through until we do that. Okay, so now that we've looped through each column, we now need to complete our average for the row. Now we can do something else at the same time. Not only can we compute that average, but we can also save it directly into our averages array. And remember that our averages array, we're going to be using the same index values here. So this is the same row value. Same row value here, right? These are the same. So we can use that same row value right here in order to put the data in our averages. So averages at row will get the value of our sum, right? But we need the average, so we need to divide by the number of columns, the number of things that we have. So we need to divide by our sales row. And the number of columns, of course, is our row.length. And I'm going to save myself because this sum is already a double, which will automatically promote this to a double here. You'll get double math, which will save it into our averages as a nice double that is not truncated. We can close our for loop, and there we go. That's real simple, quick, and easy. Okay, let's think about another case sometimes in our data. Sometimes we're not worried about everything in our data set. Sometimes we want to look at a specific slice of our data. So let's think about if we have a set of data like this. So let's assume, actually, you know, we can use this same example we had before. So let's assume we want to see what the sales was like on, say, the 5th day of every month. So it'd be index 4, right? See if I can get 4 in here. 0, 1, 2, 3. There we go. 0, 1, 2, 3, 4. So I want to see what the sales was like on the 4th day of every month. What was the sales like on the 4th day of every month? Was it different than the other days? I don't know, but I want to see what the sales were on the 4th day of every month. You got to be careful with something like this with jagged arrays, right? Because if you want to find out what the 31st is, you got to make sure that a month has that there and you're handling those exceptions, but 4 is easy. So how would we pull out just the 4th day? Well, let's think about what this data set is and how we would write this before we write the code. So if we think about, this is our columns, of course, up here, and these are our rows. This is row 0, 1, 2, 3, 4, and so on. This, of course, is 0, 1, 2, and 3, and we're looking at 4. I'm looking for just 4 here. So if I want to select this first spot here, this is going to be at sales at what position? Well, it's our row 0. Remember, rows first. And our column position of 4. Well, we move 1 down. What's that position as we look down for each month? Well, it becomes sales at 1 and 5. Oh, sorry, 1 and 4. And then it becomes sales at 2 and 4. And 3 and 4, and 4 and 4, and 5 and 4, and so on and so forth, right? And we can see what is consistent here is that I'm holding my column value constant. So I can create any variable. If I instead have having a a 4 integer in there. I change that to some variable. So I change this now to a column variable. And I now set column equal to 4. It now does the same thing. So I can do that within a method, say, and I can pass in method, a piece of data. So let's go ahead and create another simplified method header here. We're going to pass in that sales value again. And now I'm going to take in an integer of my column value that I want to read. So the first day of every month, the third day, the 5th day, the 10th day. I want to read what that column value is for every month. How would I do that? Well, I'd set up a for loop that only changes the row value. So now instead of changing row and column, I only need to change rows. So I only need one loop. So here we go. We get our row less than our sales.length, increment our row. And the beautiful part about using row and column as our variable names is that when we want to get the data out of our sales 2D array here, we use the same terminology, which doesn't confuse us. So we can do a system.out.println. I'm going to avoid writing system to save my hand here. And I could say sales at row and column. And this would read whatever column I want row by row, staying consistently and now moving vertically straight down the list wherever I want, or straight down the data wherever I want. Another nice thing that I can do with 2D arrays is I can actually pass that array, the inner array, to another method. So let's say that I want to average each row, and maybe I don't want to handle it in my current coding. Maybe I want to do some dry coding. Maybe I handle 1D array averages somewhere else. I can do something like this. So I could do something where I, let's see, pass arrays from 2D arrays. This is really cool. So now what I can do is I could do, let's assume sales here again, since we've already been thinking about this data set, and it's a name that we know. So if I wanted to say pass each month to another method for it to get handled and it to get processed, I could say for, and use an enhanced for loop here, for an integer array, and we'll call this month, since that's what we've been describing, from sales, and I could pass that to some other method. So maybe I have a method that finds and prints out the sales data. So I could have maybe a method that says print sales. And I pass my print sales my month. And this is where things get really interesting in the way that you can handle one-dimensional arrays, have your really nice, neat algorithms for them, and then simply have a 2D array that handles many of your 1D arrays and passes it to that method that you have built with your wonderful, efficient code that now does the processing. And it doesn't matter if it was where it came from, if it was from a 2D array or from 1D array or somewhere else. All right, so that is some of the cool things that we can do with 2D arrays. There's lots more to them, but these are the basics that we need for the AP exam. I'll see you guys in the next lesson.